Okay, for this one, the very first thing it asks us to do is to verify that the function satisfies the hypotheses of the mean value theorem. And the hypotheses are that the function is differentiable over the open interval and continuous over the closed interval. So we're good on functions that are polynomials, or a sine or cosine function, or an e to the x function. But we are not good here because we have a discontinuity at x equals 1, which is within this interval. So this guy doesn't even satisfy the hypotheses of the mean value theorem, so there's no work to be done. We can't find any c value that satisfies the conclusion because the hypotheses are not met. Okay, so then let's just work through these. We need basically to say that f of 2 minus f of 0 equals 2 minus 0. I'm sorry, f of 2 minus f of 0 divided by 2 minus 0, that's the average rate of change on 0 to 2, would equal the instantaneous rate of change, which is 3x squared plus 1, and I just did a quick power rule derivative there. So f of 2 is going to be 9, and f of 0 will be negative 1. So I end up with 5, and the question is, where is 5 equal to 3x squared plus 1? And I'll go ahead and do this by hand. So I have 4 equals 3x squared, 4/3 equals x squared, and back up here, x equals the plus or minus square root of 4/3. But my answer has to be on the given interval, so my only answer is going to be the positive square root of 4/3, which will be 2 over rad 3, which is 2 rad 3 over 3. The next one, I'll do a quick derivative of sine, and I will get 2 pi times cosine of 2 pi x. And then I am going to need f of 1 minus f of negative 1 over 1 minus a negative 1. So f of 1 here is going to be sine of 2 pi, that is 0. F of negative 1 is going to be sine of negative 2 pi, which is also 0. So this is actually a Rolle's theorem problem, which is just the mean value theorem where the derivative or where the average rate of change is 0. So the question is, where does my derivative 2 pi cosine of 2 pi x equal 0? And the answer is for the angles where 2 pi x equals 0. Where cosine of 2 pi x equals 0. And we know that cosine equals 0 at pi over 2 and at 3 pi over 2 on the unit circle. And I'm trying to think of, well, let's see. We know that 2 pi x equals pi over 2 and 2 pi x equals 3 pi over 2 because this angle has to equal either pi over 2 or 3 pi over 2. So if we get rid of the pi's, we end up with 2x equals 1/2, x equals 1/4. Get rid of the pi again, divide by 2 pi, and I end up with 3/4 here. Those are both in the given interval, and now I'm wondering if I've missed something, like what if I had tried, say, negative pi over 2? What if 2 pi x was negative pi over 2? That would give me that x is negative 1/4. That works in the interval as well. And what if 2 pi x was negative 3 pi over 2? When I divide by 2 pi, I get that x is negative 3/4. That works in the interval as well. So I believe I've got 4 answers here, and without looking at my key, there's a potential that I missed one, but I don't think I did. So I have 1/4, 3/4, negative 1/4, and negative 3/4. All right, and then the last question is with the e to the x. The derivative of this guy is negative 3 times e to the negative 3x. We need to set that equal to f of 3 minus f of 0 over 3 minus 0. So f of 3 is e to the negative 9. F of 0 is 1 over 3. So that needs to be set equal, let's see, negative 3e to the negative 3x equals e to the negative 9 minus 1 over 3 on the interval from 0 to 3. So I'm not going to solve that by hand. I'm going to need a calculator for this one. I'm going to pull up my calculator, and let's see if I can. I feel like my calculator's a little bit cut off, but I think I can do it. So I'm going to put in solve here, solve for negative 3 times e to the negative 3x is equal to, and my numerator is e to the negative 9 minus 1, close paren, all divided by 3, and comma x to tell it to solve for x. I don't know how long, it didn't take long at all. So let's go highlight that, bring it into my row, and hit green diamond, enter. And there's only one value where this works, and it's at x equals 0.732.